Tonight we're working on exercise 30.1, and that is not what you're seeing on your screen right now. This is actually the first sample exercise or practice exercise, I guess you would call it, in our chapter, in chapter 30. But if you go to the homework section of chapter 30, wherever that may happen to be, way down here somewhere, you're going to notice that what they ask you to do is to rewrite that example. So obviously the first step then is that you should go and download the sample files for the chapters. If you guys haven't done that yet, then you're going to end up just going back to that listing and typing it in. But if you go to the publisher's website, you can grab it. It's a big zip file. It unzips. It breaks it down by chapter, and you just find the file that's called Task Thread Demo. And so what I've done is I've copied that file, and I'm going to go into Eclipse. That's the program we decided to use here tonight. And I'm going to create a new project. And then inside that project, I'm going to create a new class. Right? Yeah. Just want to see if you guys are with me. All right, let's call it whatever you think is appropriate. And then since I already basically have the code, I grabbed it from the source. And then I'm just going to highlight all that and copy it. And then I'm just going to replace everything that's here. The one thing you'll want to change is the package declaration, or just remove it. It's probably easier. And then it looks like I'll probably have to change the name of this to match the name of my file. Oops. And then I'm just kind of scanning through it just to make sure there aren't any errors. This one's probably related to the package declaration. All right, I'm going to go ahead and save it. And that hypothetically should go away. I don't think it's anything that's going to prevent it from running. But what I would like to do now is I want to run this program as is, so we see how it operates. And we had a little bit of a discussion about multi-threading. Hopefully you guys read the book. You should read the book. And then hopefully you watch the lecture videos. That helps to explain some things too. But in essence what we're doing is we're creating 3 runnable items and 3 threads, and then we're going to execute those threads. I mean, that's the basis of what we're doing. Now, the thing that's interesting about the application, though, is notice this little thing that we're implementing. We're not extending, we're implementing what they call the Runnable interface. And that's the thing that allows for the multi-threading to happen. It's important to note, folks, that not all languages are capable of multi-threading. And I think that's kind of interesting in and of itself. So it really indicates to you that Java really truly is a higher level language because of its capability to do this in the first place. All right, so we're going to have basically these 3 different methods. Actually 2 different methods. So we're going to print characters, right? We're going to do that one twice, and then we have a different one that's called print num. And if you come down here and take a look at that, that also implements Runnable. Then if you look at what they're going to do, I mean, they're pretty simple. You know, they're basically separate class files. And the thing to remember that if it's a separate class, you know, really the best practice is to have it as a separate file. And one of the reasons the author does it this way is so it's all in one place and we're not bouncing back and forth. But they could be a separate file just as easily. As long as they're in the same folder and project, it'll read. It'll find it within the resources and it'll work. But let's just take a look at each one of these classes. We have a couple of private variables here. One's a character and one is an integer indicating how many times you're going to print it. And then, of course, we have the constructor function here. That's just basically going to receive the character and how many times it's going to run. And then we have the run command, or the run method, which is just going to do a loop that's going to keep printing it as many times as we tell it. It's really very simple. The code, I mean, there's nothing to it, basically. And for the number, it's basically the same thing, except it just works with numbers. Why, let me ask you a question. Why is it we're not passing two things into this constructor? Say that louder. Okay, well the other one's printing two characters, but we send a character to it, and then we tell it how many times to print. But see, this one says construct a task for printing. It's just going to count. Right, so it doesn't really matter. Now, the question is how high are you going to count? So it's going to start counting from 1, and the only parameter it needs is what do you want me to count up to? The loop does the counting. All right, so that aside, those are all pretty simple little tasks. Can we agree? It's not really that perplexing to think about. But the fact that we use implements Runnable makes it possible for it to become a thread. So in terms of, like, if you're ever writing code in the future and you see something like this, of course you can Google it, but now you know in the back of your head that allows it to concurrently execute. Now, the thing that makes this exercise interesting is, okay, this one is a separate class. We're running a separate thing. But this one, or these two, are doing the same thing. They're calling the same method. And we come down here and we start thread 1, thread 2, and thread 3. And normally the way that it would work in the standard program is it would print all A's, it would print all B's, and it would print all the numbers in order. Question?
Could you create statements like that too? And would you be able to just print out that? Like, for example, like the project or whatever, I want to put more questions. Could you just use that to print that?
I'm not sure why you would go to the trouble with that, because in that circumstance, like, one person's taking the quiz at a time, or the questionnaire at a time. So it's not like it really needs to run multiple things concurrently. We're just writing a really simple example here to demonstrate that if you do run things concurrently, what happens and how the computer handles it. Now, if you were writing an application where somebody, one piece of software was running the survey for 20 people at the same time, and that's how big mainframe systems work. They run one program and you get a bunch of people to connect to it. Then it would be necessary to do that approach. Does that make sense? Okay. All right, so let's go ahead and get this to run. It says errors exist. All right, let's go home. Well, it says line 4. What am I missing, folks? I mean,
Yours is, you don't have a package for yours. Yours is actually in chapter 30 exercises package.
right. I removed the package declaration, so I'm just going to You know what? I could either add the package declaration or move it to default. So I'm just going to move it to default. And I saved it. And now we're going to run it and be happy. Right? Now, you're remoting to your home machine, right? Okay. What kind of processor do you have on your machine? Right. Most people, that's okay. You don't have to be able to answer it. The young little kids can answer it. Okay. Here's how you find out. Bring up any file folder window. Right-click this PC or computer or my computer, whatever OS you're running. All right. And then look at your CPU. Now, all of us are going to have different things here. Right? So I have an i7. It's an old one. This is about a 3 or 4 year old machine. So when I bought this thing, it was pretty expensive for a laptop. But chances are most of you will have like i5, i3. You might even have like a Celeron or a Pentium or a dual core or God forbid an AMD processor, right? There's nothing wrong with them. They're just fine. They just run hot. All right, so the point is, depending on the kind of processor you have, your output can look much different. Now, wouldn't it be logical to you that because I said thread 1, thread 2, thread 3, and each one of those runs these, right? That, okay, well, I know they're going to take turns, but wouldn't it make sense that we would see A first? Yours did. Mine didn't. B didn't wait his turn. Or her turn. How many of you got an A first? How many of you got a B first? How many got numbers first? Nobody. Okay. Now the other thing you should look at the results is the numbers, right? Notice that the numbers are interspersed, right? Sometimes there's a whole bunch of them. Now what's interesting to do as this is running is, you know how we were earlier, we did the right click and we looked at Task Manager, which brought this up on the screen. And usually when people run it, now this is Windows 10, mind you, Windows 8 looks similar. You get this view and you only see your applications. But if you're not familiar with the fact that you can click this More Details button, you can see all the programs that are running. And then you also have these other tabs where you can see your performance. Now, watch what the CPU does when I execute the program again. One quick little spike, and chances are when I hit it, the threads right here changed. So notice the results this time. Now it started with an A. Once again, it was like 1, 2, 3, and then at some point, it's nothing but numbers. Now, if you want to have some fun with this, let's up those numbers a little bit. Let's make it 1,000. Yeah, well, I didn't code it to wrap. Really, the thing to do there is you could write a loop so that every 50 characters it wraps. I'm not really so concerned about what the actual output is. I pretty much kind of look at just the beginning, and you can just see that every time it's different. So this time, I'm upping it a little bit. Each one of those is going to run a loop 1,000 times. All right. Watch what happens here with the CPU. I'm going to do it. Another little blip.
Another spot.
All right. Yeah, that could be something else though. And nothing else?
No, it's probably the spacing. Probably doing that certain
All right. I paused here for a second because we had somebody that basically did this. They, instead of like setting stuff to 1,000, they set it to 10,000. And what happened is that we hit the limit of what system out print line can do, which is kind of interesting in itself, right? So, all right, and that's why the author only has it go 100 times. All right, so let's jump back over to the book and actually do what the exercise says. It says rewrite it to display the output in a text area. That's it? Right, well, we're not going to get that same exact output, you realize. All right, so if we're going to put something into a text area, what do we have to change? Well, we need a scene and a stage and a GUI and all that kind of stuff. So that's really our big task here. So, folks, this is a piece of cake, right? We already have the programming code and logic handed to us. So what we're going to do is, first thing is we're going to say up here, not from, extends application. We need that part. So then do your control space to bring up JavaFX. Now this is telling us it's got problems too. Yeah, so it basically needs the stage and all that stuff. And our habit in this class has been that we take this, oops, I was going to drag and drop it, but for whatever reason doesn't want to cooperate. Let's cut and paste it. I'm going to put that right up here at the top. Other thing I'm going to do is, as a global, I'm going to set a text area, and I'll just call it TA, which will be a new text area, parentheses, and a semicolon. Let's hover and add the library, JavaFX. And then the other thing that we're going to do is we're going to shift all the runnable code from the main method to the start method. Okay? So inside the start method, I'm going to take all this stuff. And actually, I might do a little bit different approach. No, you know what? I'm going to leave it just the way it is. No reason to change it, honestly. Maybe do an indent would probably be good. Then, of course, the main method here, we're just going to do our launch. This is our routine, isn't it? So that's where we are so far. we do need to do the whole scene and stage and all that stuff too, right? So I'm going to type this so fast you won't even hear me click the keyboard. See? All right, so here's an example of the scene and the stage. You can see I need another library here. Let's pull that in. Now, you guys saw what was happening with system out print line, where it just kept going off to the side, and at one point it just said, ah, that's it, no more, I'm done. So what would be really helpful is to maybe drop in a little bit of code up here at the top, where I'm going to take the text area and make it so that it wraps. It's just a very simple little declaration. So it's a native method. So I just say set wrap text true. And then let's look again when you guys are copying my code. It says rewrite it to display the output in a text area. This should work, right? All right, I'm going to save my code and pausing the video. I'll let you guys catch up and then we'll try it. All right, at this point we need to see what happens. So I'm going to go ahead and hit the play button here. And of course it's going to launch in a window. It's pretty exciting. What do you think? Is it working? Yours is working? All right, well, apparently we have some work to do then, huh? I don't see any errors. Why doesn't it work? John, I hear you saying something. What are you saying? I do have smart students. Somebody realized that it did actually work. It just outputted it down here. Because, right. So it did exactly what we told it to do. It did system out print line. So we need to come down here and we need to change these. And let's go ahead and change this to text area, append text. And if you want, I mean, you could do something like, you could concatenate a space in there if you wanted. That's on you. You don't have to do that. But the numbers do that. Maybe we should do that with the characters. It'd be nice to be consistent. Yeah, it kind of creates a little bit of a problem, doesn't it? It says it's a separate class, so how are we going to get it to work talking from class to class? All right, so we're trying to figure out why this isn't reading, right? Well, part of the problem is, if you notice, when we wrote this program before, we got to look at where all our curly brackets are. So, I know, as sad as it is, but that's the case. So this one matches this one, that's the stage. And then we have class declarations, but the class declarations are outside the closing curly bracket for the program. Of course it's not going to read. All right, so I'm going to just take that curly bracket and put it down here. We got to think about this for a second. The very last one. Oh, it was sitting, it was, well, let's see, I'll just Control Z. Yeah, it was after the start method. Yes. We'll put this at the very end. And I'm going to save it. Now I'm going to try to run it again. No. Well, notice it still did system out print line because I only changed one of them to text area. But boy, the AB worked pretty good. Look at that. Not only did it work pretty good, but it was looks like a better mix than I had in the past. Right, let's switch the other system out print line real quick. Try it again, and then we'll stop and solve problems. So one more run. Oh, and now I got an exception. See, teachers make mistakes too. All right, what we're going to do here is I'm actually going to pause the video. We'll try to figure out what's going on with everybody's program, and then I'll come back and fix this one too. All right, so my concern at this point is the way we have our curly brackets structured. Let's be really methodical about this, all right? So here we have our main class. That's got to close away at the bottom. Okay, that one's already matched, right? Typically, when we've written programs in the past, we have our start method, we do a bunch of stuff, and then we'll have our main method, which launches everything. Usually we put that way at the bottom, right? Let's do that. Let's put that way at the bottom. And that's going to go where? Yeah, just before the closing curly bracket. All right, so those sections are okay. We got this one to match up. This one's matched up here. We moved our main method to the bottom. Now we're going to take a look at this class. And with this class, we have this curly bracket here. I'm going to highlight it. And you can see that it's matching here. It has a constructor, and then it has a void run method here. So these match and these match. So that seems okay too. And then we have our class for print num. We'll do the same procedure. That matches, that matches. So that seems all okay. Are we okay now? All right, well, I'm going to save my work, and I'm going to hit the run button, and I see that a bunch of red errors popped up. Do you see that? But I also see that it ran.
Yeah, mine does the same thing.
It's not running quite right, right? We are breaking this, right? And if you look at the stuff that's being thrown as an error message, we are throwing way too much data at it, more than it can handle. So the text area also has a limit. So what might be not a bad thing to do is instead of running it 100 times, let's run it like 20 times. And let's save it and see if we still get an error. No error this time. So really what was happening is we were pushing, once again, the limit of the structure. A text area, if we were to look it up, would have a limitation. So for example, I know that if I put 200 in all of these, we know it's going to break, for sure. If it was breaking with 100, it's going to break here. So I'm going to run it, let it do it, let it throw the errors, and then what I'm going to show you here is if I just look at the very first little error, it says exception in thread 4, index out of bounds. And I just go ahead and click on that. It actually shows me that I can actually create a breakpoint. It's got built-in breakpoints that it says, if this happens, what happens? We suspend the thread. Right? So there's already settings built in that if we exceed the capability of whatever that text area can hold, it's going to throw this error. And it doesn't necessarily mean that the program's not working. So one way you can make sure it works is just use smaller numbers. And then when you use the smaller numbers, you're also going to see it break. Okay. Yeah, there we go. Yeah, it's not very consistent, is it? Yeah, I'm getting very, I will admit I'm getting very strange results. Now it keeps throwing errors, index out of bounds. It keeps pointing to line 57. So, remember what I did to line 57? Well, I'm like printing all these darn spaces. Oh, which one is it not liking? Oh, I see what you're saying. Ah, yeah, there you go. So you know one of the fixes for that, like brute force fix? You just concatenate an empty string and it turns it into a string. Yeah, no, but before I was also printing a space, and that was like chewing up some of the space in the text area. So let's just try that again. Okay, we're still hitting the limits on it. If you want, no harm done. Yeah, now I'm not getting any errors. Now I'm getting an error. Now there are some other techniques for doing this, folks. If you get it to work as well as I've gotten it to work, I consider that a success. Yeah, because I don't know if you're noticing, sometimes it throws the errors and sometimes it doesn't. All right, now I know you guys have all copied this code. Are you ready for me to completely change it?
Oh, 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 oh,
All right, watch what I'm going to do here. I'm going to pull in what the author's solution is to this problem. And what that means is I'm going to comment out all this stuff here. So oops. I'm not deleting it. If you guys choose to do the code I'm about to drop in, that's fine. But in my mind, I want to drop this in and I want to see what it does. All right, so take a look at this alternate approach here. Right, up top here, we create new runnables, right? We give them names. And then we create new threads that pass those runnables. So here what they're doing is they're instantiating in place. And then they're just calling it print AB100. Do you guys think this will have any bearing? Any change in result?
Yeah.
Somebody very bravely said yes. Let's see if you're right. Still throwing errors. Look at all these programs I got open too. I gotta close all of them one at a time. All right, well, run it one more time. Highly unpredictable, right? All right. Whatever way you do it, it does not matter if you're throwing errors, because the way we're writing our code seems to be pushing the bounds of the structures. And the thing is that you learn that it's not necessarily predictable as to what gets a slice of the processor. But apparently if you write the program small enough, it won't throw any errors. So you see, like right now, I only have each one running 10 times. But what I'm finding fascinating, oh, it did throw an error. All right. Since this is the only exercise we're doing in this chapter, and it's mostly to introduce you to multi-threading, like I said, I'm okay with you getting this far with it, even if it's throwing errors, because it's really kind of just introducing you to the topic. There are ways to contend with these issues, but we could, spend several hours going through it. And it's end of semester, so we're not going to do that. So this video is done. If you can do what I've done, you've earned your points.